Hello students, today we'll begin with a new chapter and the name of chapter is circles. So to start with circles, you all need to know certain lines which intersect with circle and we give names to those lines. So to start with, I'll explain you what are these lines and what are the terms which we use for these lines. First, I'll draw a line which is not passing through a circle. So we call it a line. If it is a part of line, we call it line segment. Second, I'm drawing a line whose endpoints are on a circle. Like these two are the endpoints and these two endpoints are on the circle. So this is one type of line. Then I'm drawing a line which is passing through a circle in two distinct points. Now this line is going through the circle, going in and coming out from the circle. And I'll draw one more line which is just touching the circle at one point. Now let's know how these lines are named. First of all, this line is just a line because it has no connection with the circle. It is not coming in contact with the circle in any form, in any mean. This line whose endpoints are on the circle, this line is called as chord. This line is called as chord. A line which is intersecting circle in two distinct points, the way we can see now. This line is called as secant. This line is called as secant. And a line which is just touching the circle at one point, that line is called as tangent. That line is called as tangent. Now we are going to come across these terms again and again in this chapter. Again and again you will find a secant is drawn to a circle. Immediately you have to visualize. Secant means a line which is passing through circle into a distinct point. We'll get a term tangent again and again. Tangent means a line which is touching the circle at one and only one point. Chord, whose endpoints are on a circle. That line segment is called as chord. So terms are chord, secant, tangent and a line which has no connection with the circle. In fact, all these are lines only, but accordingly the way they come in contact with the circle, we name them. Right? Chord, secant, tangent and a line. Now in this chapter, circles, the most important theorem is tangent perpendicularity theorem. The most important theorem is tangent perpendicularity theorem. Now this theorem will be the benchmark, this theorem will be the base mark for this chapter because all problems will evolve in relation to this theorem. Now this theorem says that a tangent at any point on a circle is perpendicular to the radius through that point. This means that if there is a circle and in this circle, if I am drawing a tangent, I am drawing a tangent which is just touching the circle at one point. If I name this line L, this tangent as line L, so this line is a tangent now. Now as per this theorem, this tangent will be perpendicular to the radius and we all know radius is nothing but a line which is drawn from the center of the circle to the circle. So this tangent is there. If I draw a radius, then according to this theorem, tangent perpendicularity theorem, this angle will be 90 degree. If I name circle as center of the circle as O, normally we mention O only as the center of the circle, then we can say line L is tangent to the circle, and if I name this point as P, this P is point of contact. So we can say that OP is perpendicular to line L. I'll write the statement. Tangent at any point on the circle is perpendicular to the radius through that point. Through that point. So we can make out a line tangent, center of the circle, P point of contact. So line L is perpendicular to the radius. So we can write this way: OP radius, line L tangent. Then according to this theorem we can say that OP is perpendicular to line L. How we got this? By applying tangent perpendicularity theorem. So remember this theorem this way: whenever tangent is given to you, it is perpendicular to the radius. Any sum, any circle tangent is there, you know the center of the circle, point of contact, center of the circle is joined, that line will be a tangent. Next, we'll do converse of tangent perpendicularity theorem. Converse tangent perpendicularity theorem. Now, according to this theorem, if a circle is given to you and there is a line, we don't know whether that line is a tangent or not. We are not aware, but we know from center of the circle, radius is making 90 degree with that line. Again, understand, don't get confused with the first one. In fact, this theorem is just the opposite, just the converse of the first one. Known to us, radius is making 90 degree angle with a line at its outer end, then that line becomes a tangent. So if I name this as L, center is O, point of contact as P. So if it is given to us, OP radius, like last time, it is known to us, angle P 90 degree, then by applying this theorem, we can say that line L is tangent. Line L is tangent by applying converse of tangent perpendicularity theorem. So I will write this statement also for this. A line perpendicular to the radius, any line which is perpendicular to the radius at its outer end is tangent to the circle. Is tangent to the circle. This is the statement for converse of tangent perpendicularity theorem. I'll again translate this properly. कोई भी लाइन रेडियस के आउटर एंड में, अभी रेडियस का ये इनर एंड है, ये आउटर एंड है, कोई भी लाइन जो रेडियस के आउटर एंड में 90 डिग्री एंगल बना रही है तो वो लाइन टैंजेंट हो गई. अगेन, कोई भी लाइन जो रेडियस के आउटर एंड में 90 डिग्री एंगल बना रही है तो लाइन टैंजेंट हो गई. इसका मतलब ये हो गया, अगर यू मस्ट बी थिंकिंग कि व्हाई नॉट दिस लाइन, अगर ये लाइन भी 90 डिग्री एंगल बना रही है, बट ये जो 90 डिग्री एंगल बन रहा है वो रेडियस के आउटर एंड में नहीं बन रहा है. कंडीशन क्या है? रेडियस के आउटर एंड में कोई भी लाइन 90 डिग्री एंगल बना रही है तो वो लाइन टैंजेंट है. प्रीवियस वन, अगर लाइन टैंजेंट है तो रेडियस के साथ में, जो रेडियस है उसके साथ में 90 डिग्री एंगल बन रहा है. अ लाइन विच इज अ टैंजेंट जो कि रेडियस के साथ है तो वो 90 डिग्री एंगल बनेगा. इन सिंपलेस्ट वर्ड, इफ अ लाइन इज टैंजेंट, इन अ सिंपलेस्ट वर्ड, if a line is tangent, angle formed with radius is 90 degree. Again, if a line is tangent, जो radius के साथ angle बनेगा वो 90 है. Converse, अगर radius है तो उसके outer end में 90 degree angle बन रहा है तो जो line form हो रही है वो tangent है. Right? So far we have done two theorems: tangent perpendicularity theorem, converse of tangent perpendicularity theorem. Before that, we have understood the concept of tangent, secant and a chord. Now we'll do one more theorem now. This theorem is, I'll write it down यहाँ पर. Theorem is tangent segment. This is a new theorem now. Rather, third theorem of this chapter. Tangent segment drawn from exterior point of a circle are congruent. Tangent segments which are drawn from exterior point of a circle are congruent. So there is a circle and from outside point of a circle, say this is the circle, from an outside point I am drawing two tangents, one over this side and the other this side. Now these two are tangent segments. Segment means till the point of contact. So if I take P as a point, AB as point of contact with the circle, then as per this theorem, as per this statement, tangent segments drawn from an exterior point of a circle are congruent. Circle के बाहर से अगर मैंने दो tangent segment draw किए तो दोनों की length same होगी. This means given to us, say circle center is O, given center is O, PA and PB are tangents. PA and PB are tangents. Call it tangent or tangent segments, both are same. So PA and PB are tangent segments. We need to prove according to this theorem. We need to prove PA equals to PB. As per this statement, circle के बाहर से there are two tangent segments drawn, PA and PB. According to this theorem, अगर ऐसा होता है, सर्कल के बाहर से आपने दो tangent segment draw किया है, तो दोनों की length equal है, ये हमें prove करना है. That is PA is equal to PB. Proof of this, what we are doing is, we are joining OA and OB. OA and OB we have joined. Construction, join OA, OB. Now we will do the proof of this. Also, we need to join OA, OB and OP. So three things I have done. Now we can consider two triangles. That is triangle PAO and triangle PBO. We take these two triangles PAO and PBO. Now in these two triangles, if we get three reasons, we can say triangles are congruent. Now we know congruency. We know test of congruency. किसी भी triangles को अगर congruent proof करना है, तो हमारे पास कुछ test होते हैं, like SSS test, side test of congruency, side angle side test. I hope you have done this in your earlier classes also. In fact, you must be doing repeatedly in geometry. So SSS test, SAS test, SAA test, and there is one more that is called as hypotenuse side theorem. Make sure your concept regarding these tests are very clear. To prove two triangles similar, हम लोगों को ये चारों में से कोई तो भी एक टेस्ट यूज करना पड़ता है, और आप लोगों का कॉन्सेप्ट इसमें बहुत क्लियर होना चाहिए. यहाँ पर we have taken triangle PAO and PBO. ये दोनों ट्राइंगल हमने कंसीडर कर दिया है. अगर हमको कोई टेस्ट यूज करना है तो हमको कंडीशंस मेंशन करनी पड़ेंगी. सो हैव अ लुक. इन दीस टू ट्राइंगल्स, एंगल PAO is equal to angle PBO, each 90 degree. Both angles are 90 degree. Why? By tangent perpendicularity theorem. See how we are using this theorem now. Tangent perpendicularity theorem says that if a line is tangent, makes 90 degree angle with the radius. It is given to us. PA is a tangent, O center. So this angle has to be 90. Angle has to be 90. So each 90 degree. Reason for this is tangent perpendicularity theorem. So by tangent perpendicularity, these two angles are 90 degree. Then we can make out OA is equal to OB, right? OA is equal to OB and OP is common. OA is equal to OB, because this is radius for the same circle, so I'm writing radii. Also, we can make out OP is equal to OP, or you can write PO equals to PO. Common side. Now, can you guess by which test we can prove these two triangles similar, these two triangles congruent? Guess करो कौन से टेस्ट से ट्रायंगल सिमिलर हो रहा है? हम लोगों का एक एंगल 90 मिला है, ये साइड इक्वल है और ये साइड कॉमन है. You must be guessing SAS test, that is side angle side. But if you are guessing SAS, unfortunately you are wrong. Why? I'll tell you why. For side angle side, there has to be two sides and included angle, right? For side angle side test, there should be two sides of a triangle, और वो एंगल जो साइड्स के बीच में आता है, जो उसके बीच में इंक्लूडेड है. यहां पर हम लोगों की जो साइड्स हैं, ये दोनों साइड कॉन्ग्रुएंट है. OA इज इक्वल टू OB, और जो OP साइड है वो कॉमन है दोनों में. नाउ इफ यू लुक एट ये दोनों साइड, एक ये साइड ट्रायंगल का, ये दूसरा साइड है, वैसे ये एक साइड है, ये दूसरा साइड है. ये दोनों के साइड के बीच में ये एंगल आ रहे हैं, और ये दोनों एंगल हमें मालूम नहीं है कॉन्ग्रुएंट है कि नहीं है. रादर हमने ये एंगल मेंशन किया है. यहां पर जो टेस्ट एप्लीकेबल होगा वो होगा हाइपोटेन्यूज साइड थ्योरम. हाइपोटेन्यूज साइड थ्योरम का मतलब होता है किसी भी दो राइट एंगल ट्रायंगल्स में अगर हाइपोटेन्यूज और वन मोर साइड, एक हाइपोटेन्यूज अदर देन हाइपोटेन्यूज वन मोर साइड, दूसरे ट्रायंगल के करस्पॉन्डिंग हाइपोटेन्यूज और वन मोर साइड के कॉन्ग्रुएंट है, तो ट्रायंगल्स कॉन्ग्रुएंट हो जाते हैं. दिस इज हाइपोटेन्यूज साइड थ्योरम. यहां पर सेम थिंग इज हैपनिंग. ट्रायंगल राइट एंगल ट्रायंगल है, बिकॉज हमने मेंशन किया है एक एक एंगल 90 है, वन साइड एंड अदर साइड, तो कंडीशन मैच्ड, हाइपोटेन्यूज एंड वन साइड. देयरफॉर वी कैन से दैट ट्रायंगल PAO congruent triangle PBO by hypotenuse side theorem. I write in short hypotenuse side theorem. Now, once triangles are proved congruent, we can write corresponding sides are congruent. We wanted PA is equal to PB, PA, PB are corresponding side. Therefore, PA is equal to PB. Therefore, PA is equal to PB. Hence, we got the result for tangent segment from exterior points are congruent. Three things before that, some concept of this chapter. Again, tangent, secant, chord. Make sure that you are very clear using these terms. Plus, your pronunciation has to be very clear. Loudly, you must say tangent, right? Tangent, secant, chord. Don't get worried about terms. Tangent, secant, chord. First theorem, tangent perpendicularity theorem. Second one, converse tangent perpendicularity theorem. Third one, tangent segments which are drawn from an exterior points are congruent. For that, I have given you the proof also.
No more spending your energy and money on coaching classes or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
So we'll take some problems based on theorems which we have done just now, some time back. In the last session, we have done tangent perpendicularity theorem, converse of tangent perpendicularity theorem, and length of tangent segment from exterior points are congruent. These three theorems we have done in the last session. So let's take some problems based on it. So this will be 2.1, Maharashtra State Board 2.1, first sum it will be, right? So I'll take that problem first, 2.1, first one. Say a circle is given to us and some more conditions are given. These conditions are AB is given to us and AB is a tangent at point T. At point T, AB is a tangent, so I'll write it down, given to us P center AB tangent, and radius is 6 centimeter. So I'll write down radius is equal to 6 centimeter. So I'll draw this P center. This is point P. P is the center of the circle. AB is a tangent. Radius is 6 centimeter. And angle PTB, I am joining P and B also, given to us. Angle TPB is equal to 60 degree. This angle is given to us 60 degree. This is also given. We need to find out PB. To find PB. Again I repeat what all is given to us. P is the center of the circle. AB is a tangent to the circle at point T. Radius of the circle is 6 centimeter. We need to find out PB. Solution. Radius is 6, so I mentioned this also as 6. Radius is this part. 6 centimeter. We need to find out PB. Now first of all, P center, AB tangent. This is given to us. See how I am writing? Given. This is also given to us. Now we have done tangent perpendicularity theorem, which says that radius, tangent, this angle has to be 90 degree. P center, so obviously this becomes radius, tangent, radius, tangent. So angle has to be 90 degree. So we are using that theorem now. Therefore, I can say angle T is equal to 90 degree. Have a look how we have used this theorem, tangent perpendicularity theorem. We got this result by using tangent perpendicularity theorem. Now, look at triangle PTB. In triangle PTB, this angle is 60 degree. This angle is 90 degree. So don't you think we can apply 30, 60, 90 triangle theorem? We need to find out PB. So we can apply 30, 60, 90 triangle theorem. So in triangle PTB, angle TPB 60 degree given. Angle T 90 degree. Just now we have proved. Therefore, there is one more angle left. This is that angle. There is one more angle left. And we all know sum of three angles 180 degree. Now out of 180, 90 plus 60 is 150. 90 degree plus 60 degree is 150. Remaining is 30 degree. So we can write, therefore angle B is equal to 30 degree, third angle of a triangle. So sum gives you 180. Now over here we can apply 30, 60, 90 triangle theorem now. We can apply 30, 60, 90 which we have done in similarity. Now you can make out, this 30 degree we have got, side opposite to 30 is half of hypotenuse. If you apply 30, 60, 90 now, side which is opposite to 30 is PT. Therefore we can write PT is equal to half of PB. Reason is 30, 60, 90 triangle theorem. Therefore, we can write 6 is equal to half of PB. Therefore, PB becomes 6 into 2, that is 12 centimeter. This is what we were looking for. We wanted PB only. So PB we got as 12 centimeter. So in this sum, two things were used. One, tangent perpendicularity theorem. Second, 30, 60, 90 triangle theorem. And we have got the answer for first one. We'll take one more sum from the same 2.1 and that will be your second sum. Just to make sure that you know the concept very well. Just to ensure जो theorems हमने अभी सीखे हैं उन theorems का application, उन theorems को problem में use करना आपको आना चाहिए. इसके लिए अभी हम लोग second sum लेते हैं. In the second sum, there is a circle given. Lines are drawn like this. This is your textbook sum only. Points are M, N and A. Now things which are given to us, that point A is the center of the circle. I'll write down point A center given to us. Then after that, AN is equal to 10 centimeter. AN 10 centimeter. Values also given to us. NM is a tangent. NM is a tangent given to us. We need to find out radius. Radius find out करना है. MN की value हमको दी हुई है 5 centimeter. We need to find out radius. So I'll mark it down in the figure what all is known to us. First AN 10 centimeter. So I'll write down 10 centimeter. NM is tangent. MN given to us 5. MN is given to us 5. We need to find out radius. To find out radius, I have to join MN construction. Join AN. Not MN, it is AN. So we have joined AN. So we need to find out AM, which is the radius now. Now let's see how we are going to get the answer for this. Solution. Now, tangent is given. Radius is given. So don't you think by application of tangent perpendicularity theorem, angle M has to be 90 degree? So I'll write that only. MN tangent given. AM radius. Why radius? Because A is the center. So I'll write A center given. Therefore, angle M equals to 90 degree. Again, we have applied tangent perpendicularity theorem. So angle M we got 90 degree. Now don't you think we can apply Pythagoras theorem? 90 degree angle, one side is known, second hypotenuse is known, third side we can find out by using Pythagoras theorem. So we'll be getting the answer by using Pythagoras theorem. But I want to talk to you one alternate method also. Just think over it and you will come to know that we can get the answer by alternate method also. This is 5, this is 10, this is 90 degree. Now think of 30, 60, 90 once again. 30, 60, 90 triangle theorem says that जो side 30 के opposite है वो hypotenuse का half है. Again, side opposite to 30 degree is half of hypotenuse. For 2 minutes, think of converse. For 2 minutes, think of converse of 30, 60, 90 triangle theorem. Converse क्या है? किसी भी right angle triangle में अगर कोई side hypotenuse का half है, तो वो side के opposite जो angle होगा, angle opposite to that side will be 30 degree, and angle opposite to root 3 upon 2 side will be 60 degree. Over here, 90 degree. We can make out one side is half of it. We can make out one side is half of it, right? That means this is 30, 60, 90 triangle theorem. So 5 is opposite of 5 is angle A. That means angle A is 30 degree. Angle N is 60 degree. So if this angle is 60 degree, this will be root 3 upon 2 times of hypotenuse. So root 3 upon 2 into 10, that will give you 5 root 3. So AM is 5 root 3, right? This was the alternate method. You can use this method also, but I'll be getting the answer by using Pythagoras theorem. But our answer will come as 5 root 3 only. See you now? So we got angle M 90 degree. Now in triangle AMN, angle M is 90 degree. Already we have proved this. Therefore, I can apply Pythagoras theorem now. AM square plus MN square equals to AN square. This is by using Pythagoras theorem. Therefore, AM square plus 5 square is equal to 10 square. I have substituted the values of MN and AN. Therefore, AM square is equal to 10 square minus 5 square equals to 10 square is 100, 5 square is 25, gives you 75. AM under root 75. AM, if you look at 5 5s are 25 into 3, 75. So AM gives you 5 root 3 centimeter. Just have a look how we got 5 root 3. That also I'll explain. 75. We are taking out the factors now. First we can start with 5. 5 ones are 5, 5 fives are 25, 5 threes are 15, 3 into 1 is 3. So when we are taking square root, 2 times 5, 1 time will come out, 3 is left, so that will go in root. So AM is 5 root 3. So you have seen how well we have applied tangent perpendicularity theorem and converse of and Pythagoras theorem in this case. Rather, we have also used 30, 60, 90 in one sum. So you really have to do practice. After seeing this, I really want you to spend some time and do a practice of these two sums. Apply theorems in problems. There you have a winning edge. The winning edge is you know the concept. Now you need to apply those concepts. There you are going to have a upper edge. So we'll take one more sum now. That will be third sum of your exercise. Now in this sum, there is a figure drawn and there are two tangents drawn from exterior points. There are two tangents drawn from exterior point. Center is given. This is how figure is drawn. Points are P, M and N and the center is O. So I'll write it down what all is known to you in this sum. Question is Q is the center. So this is point Q. So given Q center of the circle. After that PM and PN are tangents. PM, PN tangents. This is also given to you. PM and PN are tangents. Angle MPN is also given. Angle MPN is given to you 40 degree. You need to find out angle MQN. We need to find out angle MQN. So I'll mark it down what all is given to us. First, angle MPN 40 degree. So there's MPN, so this angle is 40. PM, PN are tangent, Q is the center of the circle. Now in this sum, you can make out these two are tangents, right? So angle with the radius has to be 90 degree. So angle M 90 degree. Why? Because it's a tangent, it's a radius. Tangent makes 90 degree angle with radius. Tangent perpendicularity theorem. Again, tangent, radius, angle will be 90 degree. Tangent perpendicularity theorem. This angle is 40 degree. Now we can make out it's a quadrilateral now. It has got four sides. So it is a quadrilateral. Sum of angles of a quadrilateral is 360 degree. Right? Like in a triangle, sum of three angles 180 degree. Same way, in a quadrilateral, sum of four angles is 360 degree. Now out of these four angles, these three angles are known to us. Which are these three angles? 90 degree, 90 degree, that sum is 180, plus 40, sum is 220. Now if we subtract 220 from 360, because sum is 360, don't you think we'll get this angle? So 360 minus 220, that gives you 140, right? So your answer should be 140 degree. So just see how I'm writing this now. So I'll write this down this way. Q center given. PM, PN tangents. This is also given to us. Therefore, angle M equals to 90 degree. Angle N equals to 90 degree. Reason for both is tangent perpendicularity theorem. Also, angle MPN 40 degree. This is also given to us. Therefore, the remaining angle is angle MQN, which we need to find out. Angle MQN is equal to 140 degree. How we got this? Fourth angle of a quadrilateral. Fourth angle of a quadrilateral, like how we write third angle of a triangle. This is your fourth angle of a quadrilateral. Three angles like 90, 90, 180, 220, 360 minus 220 gives you 140 degree. This is how we got the answer for MQM as 140 degree.